Well, while I get things arranged with my band, The Noodles, I'm going to send you to Ruffner Middle School in Norfolk, Virginia, where you'll see students from the classroom of science teacher Miss Susan Begay and math teacher Mr. Stephen Davis. They're conducting an experiment examining the speed of sound. Follow along, and after that, you can make your own analysis and predictions based upon their results. So I'll catch y'all later.
Hi, we're students from
Ruffner Middle School in Norfolk, Virginia.
NASA Connect asked us to investigate how sound waves travel at different speeds under various conditions. In this project, we'll be measuring the speed of sound and calculating the percentage of error with our science teacher, Miss Begay, and our math and science teacher, Mr. Davis.
To prepare the experiment, pour 1 or 2 tablespoons of powdered sugar onto the middle of 4 sheets of tissue paper. Pull up the corners and tie it with string. Make 4 bags for the experiment and 2 additional bags in case of accidental breakage. Now we're ready to go. First, we record the wind direction, weather conditions, and outdoor temperature in Celsius. Next, we mark the spot where the sound engineer will hit the pots. From this point, we measure out 50-meter intervals. The linear speed engineer teams are located at each of these intervals. The sound assistants hold up the bulletin board paper to create a dark background behind the sound engineer, which will help the speed engineers to see the puff of smoke.
The sound engineer tapes one of the bags of powder to the middle bottom of the pan. When the sound person hits the 2 pans together, bursting the bag of powder, the linear speed engineers start their stopwatches at the first sign of smoke and to stop them as soon as they hear a sound. Warning, be ready to use a quick reaction time. Ready, set, go. The experiment is performed at least 3 times to get a range of data. Now we return to the classroom to analyze data.
Mr. Davis gives us the formula for determining the speed of sound. Speed equals distance divided by time. Using the data collected, we calculate the speed of the sound at each location. We compare results between the locations. Mr. Davis asks, what do these numbers represent? Next, each group calculates the accepted value for the speed of sound at the recorded outside temperature. After we have posted our results, Mr. Davis asks us to calculate the percentage of error in the experiment using the following formula of amount of error divided by the accepted value times 100. We had a good time applying math to solve a problem.